Example 1. Drawing a normal quantile plot by hand. Data set 31, commute times in Appendix B, includes commute times minutes obtained from Dallas, Texas. Let's consider this sample of the first 5 commute times, 20, 16, 25, 10, 30. With only 5 sample values, a histogram will not be very helpful here. Instead, we want to construct a normal quantile plot for these 5 values and determine whether they appear to be from a population that is normally distributed. So for step 1, the first thing we want to do is sort the data by arranging them in ascending order. So we want to make sure that we start with the lowest number and end with the highest number. So therefore we're going to get 10, 16, 20, 25, and 30. So if you look over here, we created a table. So the first thing we want to look at is the commute times. So we're going to put this in the first column. So therefore we have our 10, 16, 20, 25, and 30. Okay, now we know that there's 5 samples, so with a sample of size n equals 5, each value represents a proportion of 1/9 of the sample. Using the known sample size n is equal to 5, we want to find the values of 1/2 times n, 3/2 times n, 5/2 times n, and 7/2 times n. And 9/2 times n, because we have 5 values. So there's 1, 2, 3, 4, 5. Now these values that we get are the cumulative areas to the left of the corresponding sample values. So we're creating this table to the right in the second column to determine the cumulative left areas expressed in decimal form. So let's take a look at this one here. We have 1/2n, which is the first one. Well, n again is equal to 5 because we have 5 sample sizes. So we're going to have 1/2 times 5, which is the same thing as 1/10. And now let's write that as our decimal, which is 0.1000. Okay, so we saw the value for 1/2n. Now the second value is going to be 3/2n. So therefore, this is going to be 3/2n. And again, what we're going to plug in is the value of 5 for n because we have 5 samples. So that's going to be 3/2 times 5, which then becomes 3/10. And therefore, that area is going to be 0.3000. Okay, the next fraction we're going to have is 5/2n. So therefore, this is going to be 5/2n. And again, the value that we're plugging in for n is 5. So we have 5/2 times 5, which gives us 5/10. And therefore, that gives us a decimal of 0.5000. Okay, the next number we have is going to be 7/2n. So therefore, we're going to take 7/2n. And again, we know that n is equal to 5, so it's going to be 7/2 times 5, which is 7/10. And if we write that as a decimal, it's 0.7000. And the last one is 9/2n. So therefore, we're going to have 9/2n. Again, we're replacing n to be 5. So this is 9/2 times 5, which is 9/10. And therefore, that gives us 0.9000. Okay, now what we want to do in step 3 is we want to use the standard normal distribution. We can use either the table A2 or StatCrunch to find the expected z-scores in the third column that we're going to get corresponding to the cumulative left areas found in the second column. So we're going to open up StatCrunch. So here's StatCrunch, okay? And so what we want to do is we want to find out what is the z-score that's associated with this area, 0.1000, and it's to the left. So we're going to go ahead and select Stat, and then go to Calculators, and then scroll all the way down to Normal. Okay, we want to make sure our mean is 0 and our standard deviation is 1, and we want to make sure this is going towards the left. So now what we're going to do is we're going to put the area in so we can find out what the z-score is. So we're going to put in 0.1000, and select compute. Now we get negative 1.28, rounding it to 2 decimal places, for our z-score. So there's our z-score, negative 1.28. Okay. Then we're going to go ahead to options, select refresh. Alright, so we have our mean of 0, standard deviation of 1, the arrow is pointing to the left. Now we're going to put the area of 0.3000 and then select compute. And therefore we get the z-score of negative 0.52. So over here we get negative 0.52 as our z-score. Come back up here, let's hit refresh again. Again, we have the mean and the standard deviation of 0 of 1, the arrow is pointing to the left. Now we're going to put in 0.500, and therefore we get a z-score of 0. So therefore this is going to be 0.00. Again, let's come up here, select refresh, and the options, 0 and 1. Now we're going to put in the area, since it's pointing the arrows to the left, of 0.700. And then we get 0.52 as our z-score, and that's positive 0.52. And again, come up here, hit options, select refresh. We have our mean and standard deviation of 0 and 1. This point to the left. Now we're going to put in 0.900, and therefore we're going to get positive 1.28, and therefore now we get our 1.28. Okay. Now the next thing that we want to do in the last column is, in that last column, what we want to do is we want to create an ordered pair. Okay, and so in that ordered pair, okay, we're going to pair the original sorted Dallas commute times with their corresponding z-scores. Okay, and we're going to get x and y coordinates in the fourth column and plot them on the graph. So let's take a look here. We have our value of 10, which is the first part of our ordered pair, which is x, and then the z-score represents the y value. Okay, next, we know the next commute time is 16, and the corresponding z-score for that is negative 0.52. And then we have the next value of 20, and then the corresponding z-score for that is 0.000. The next ordered pair, we know that the value of the commute times is 25, which is x, and the z-score is 0.52. And then we have 30, which is the value for x, and the z-scores correspond to that is 1.28. So now that we have our ordered pairs, we get the points x, y coordinates in that fourth column that we have, and then we want to plot them on the graph. Now, when we plot them on a graph, let's first recognize that the horizontal axis is going to represent the z-scores. And then we can say at the bottom of the graph is going to represent the commute times. And so now we want to plot those points. Well, the first ordered pair that we have is 10, negative 1.28. So we're going to find 10 on the graph on the x-axis and then go down negative 1.28. So it would be somewhere, I would say around here, because that is in between negative 1 and negative 1.5. So therefore this ordered pair is going to represent 10 and negative 1.28. Okay, the next ordered pair is 16 and negative 0.52. So we have 16, and then we're going to go to negative 0.52. So that'd be somewhere around here. And so therefore this is going to be 16 and negative 0.52. Okay, the next ordered pair is 20 and then 0. So right here at 20, that is 0. So we're going to write 20 and then 0.00. The next ordered pair is 25 and then 0.52. So if we go to 25, and then this is approximately 0.52. And then we have 30 and then 1.28. So if we go to 30 and then about 1.28 is actually just a little bit above that. So that is 30 and then positive 1.28. Okay, now we're not necessarily going to be able to connect this line and get a perfect line if we connect these dots. But what we want to do is we want to draw a line, okay, through those points just to make sure that, yeah, does this resemble a possible normal distribution? So if we take our line, right, and just draw it through some of those points, are those points connecting a possible line? Well, the answer is yes. So therefore, for step 5, the interpretation will be the following. We examine the normal quantile plot, and the points do appear to lie reasonably close to the straight line. So we conclude that the sample of 5 commute times does appear to be from a normally distributed population.